Okay, so today we will see this problem of how to sort a given uh, list of names. You are able to see my screen, right? Okay, great. So like for example, if you take this file names.txt, so this is a file which contains one name per line, and you can see certain names are repeated, like Krishna is here, and you can see Krishna again here and again here. 3 times it got repeated. So like that, some names are repeated uh, in this list. All right, and yeah, so if you in Unix, on most Unix systems, you have a sort function which says sort names.txt. If you give this thing, then it will sort the names and print it on the screen. So do you have a Binod in your class? No, no. All right. So, and if you want to sort the names in the reverse order, you just give sort minus r. And if you minus r means sort in reverse order. So, and if you want to write the sorted names into a different file, you can do something like, sort names dot sorted dot text. Then the sorted names will be written into that file. So if you, and then if you see like that file, you can see, that file contains the sorted names. So this is the problem at hand. Like, how do we write a program to sort a given list of names, and possibly no, have an option to see if you want to write the sorted list into yet another file. Okay. So now we want to more, if there is a very big, if the file is large, you can scroll through that file. Like for example, right now the screen is large to show everything, but let's say I have something like this. My terminal is small now. So now when I do more, it waits, it shows the part of the screen and it waits. And if I press enter, then I keep scrolling through the rest of the lines of the file. That's what more does. And what should you do? So you should all, whenever you are in doubt, man more. So man more will give you stuff. Like for example, anyway, this class is not about more, so forget about it. Okay, so now we would like to write a program to solve this problem, this sorting problem. So the problem is, you read from the keyboard a list of names and you you print the sorted list on the screen. That is the problem that we start with. And my first question for you is, when we are about to solve a problem, what is the first design question that we should make? The problem is, you read a list of names from the input from the keyboard, and you have to print the names on the screen in a sorted as a sorted list. How do you do it? Yeah, so what the question is, what is the first question we should be asked? So as Ananya rightly said, the first question is, how do you store the data? Okay, so how do we store this data? If you are reading a list of names from the keyboard, how do we store this data? Like for example, in order to for you to get a feel, this is what we will be doing. So maybe let's say, so like this, as we are reading, the program is reading this from the keyboard and it is storing internally. So what data structure? So it should, and when we press Control D, that is end of file character, it prints the names in sorted order. So the data is one data structure that we can use, which Vitish is suggesting is use a 2D character array. That's a good start. So this is a program actually last semester when I was working with section A students. So we wrote this program, but now we are just using the same program. We will go through the program a bit slowly though. So if you see here that the data structure that we use to store our list of names is a 2D character array. And you can see that max underscore list is a macro. It is of length 100. It is defined as equal to 100. And max name underscore length, it is also a macro and it's defined as equal to 20. So here we are, here we are essentially declaring a 2D array of 2D array of dimensions 100 by 20. It is 100 rows and 20 columns, and each element is a character. It's a 2D character. And our idea is to store, this is our 2D character array, and our idea is to store our names, the names that we read in each line, in each row of this 2D character. Like this is row 0, this is row 1, this is row 2, so on and so forth. And this is row I. And if you keep going, so you have, this is you have 100 rows. And then of course, no, this each, there are multiple columns. So this is column 0, this is column 1, this is column 19. And if you are storing some name, like for example, so if you are storing some name like Venu, so you store the ASCII character values associated with and then every string, it is terminated by null character. So this is how we store the list of names in our data structure. Every row of our structure, this 2D character array, it stores a name. And that name, it's we store names as a string. And what is the convention that we follow? That we use a null character to terminate a string. So that means if each row length is 20 characters, then the maximum name length is 19 characters, because we need one more character for to store the null symbol. And what we do is, this is our data structure, and then we use there is a function. There are 3 functions in this program. The one is read names, using which we read the names from the keyboard, and it returns the number of names read from the keyboard. And names contains the base address of the character array. So are you with me here? So names, it's an array name. Names, the variable names, it's an array. So it can store the base address. It can store the base address of the character array, of the 2D character array. So because of that, the read names function knows, since it knows the address of all these entities here present in this 2D structure, it is possible for it to fill it with appropriate characters. Are you with me here on line 56? Because we are passing to read names function the base address of the 2D array names. Since we know the base address, once we know the address, the base address, this the address of this, then we know the address of all the elements in this array, and it is possible for us to fill in those cells or the memory cells with the appropriate characters based on what we are reading from the keyboard. The second function is the sort names function. That function takes two parameters. Again, it takes the base address of the array and it takes the number of names read from the keyboard, and then it sorts them out. So again, this is sort names function is interesting because the names are sorted in place. That is, we don't create a new list of sorted names. The list remains the same, but within that list, the names will be rearranged so that they are in a sorted order. And finally, we have the third function, which is the print names function. We use the print names function to print all the names on the screen. Are you all with me so far in the structure of the program and what we are doing? Okay, great. So now let's see. So we will go through each of these functions one at a time. So let's look at the print names function. So sorry, the read names function. So in the read names function, what I would like you to again observe is the function signature or the type signature. If you see the type signature, so it returns a value of type integer because the number of names read, and it takes as parameter a 2D array, and this can be inferred or this is specified by using this particular syntax. That is, the first dimension will be empty. We use an empty square bracket. And the second dimension, we use and the second dimension, what do? We use we have to specify the length of the second dimension. That is the number of columns. This is how we specify the arguments, a multi-dimensional array arguments, when we are passing multi-dimensional array as a parameter to a function. We discussed this a few classes back. Do you recall this discussion? I hope you all recall this discussion. So why it can be, this can be empty, why this cannot be empty, we had some good discussion there. So in case you forgot, please go back and refer to it. So now what we do is, as soon as we enter this function, so on line number 10, what do we have? So I is equal to 0. That means, I keeps track of number of names read. So yeah, no names are read. So I is equal to 0. And then on line 11, so we have a while loop with a scanf. So what this does is it reads a name and stores it in the ith row. And scanf returns the number of number of values successfully read. So if it reads one string or one name successfully, it returns 1. But if you have anything like if you press Control D or something like that, then it returns a value other than 1, in which case we come out of this loop. So we keep iterating in this loop, and as we keep reading names, we keep incrementing the counter, right? Because it keeps track of the number of names read. And at some point, if I is equal to max list, that is maximum number of elements, then we break from the loop and come out. Then we return I. There is no names in this function, so you just number of names actually. But if you look at line 8 to 19, focus on line 8 to line 19. So you are just using no, I to keep track of the number of names that you are reading. We cannot put space at Git. In this one, a name cannot have a space in this particular way of reading. Good question, Git. And second important thing is, when we want to read the ith name, we have to pass the base address of this ith row, and the base address of this ith row is nothing but the base address of the 0th element of the ith row. So because of that, we are using this ampersand symbol that gives the base address of the ith row, 0th element of the ith row. So this whole thing, this ampersand thing, it yeah, if you want to take space, you can use getS function. Yeah, that's true. So it gives the address. This whole thing, this whole ampersand name size 0, it gives the base address of the ith row. So from what I figured out, so instead of using this, you can even use just name size. Yeah, even name size should work. That's what I gather. But what I wanted you to understand here is the conceptual thing, that in order to read this, in order to read something from the keyboard and write into this, into this row, we need to know the base address of this row. And the easiest way to get the base address of this row is just by referring to finding the address of the 0th element of the ith row. Right? And then, but there is an alternate option, so which seems to be, you can use the names of I here, which is the pointer to the ith row. It seems that's the semantics of the C. I didn't read it, this particular point carefully in the book, but it looks like names I will also work. Are you all with me on the read names function? You understand, right? What's going on? And the print names function is, again, it's very simple. So it has two parameters. One parameter is the base address of the array, and the second parameter is the number of names. So you just have a loop where you print. And again, for printf, you have to pass the base address of the string that you would like to print. So because of that, if you want to print the ith row, you take the address of the 0th element of the ith row and and pass it as the second parameter to printf. So that is how read names and print names things work. Are you with me here? Shall I move on? Okay, great. So now let's see. I want you to, before, I want you to understand, take a look at this function, swap function, which which uh, which swaps two strings, two strings. So here, uh, there is a bit of a catch here. I will ask you what is the problem there. So how is this working? Let's say there is a string here, there is a string here, and there is another string here. This is str1, this is str2. So you want to swap these two strings. So what we do is we are creating a temporary buffer and we are copying this string to here. This is step 1. And then we are copying this string to here. This is step 2. And we are copying this string to here. This is step 3. So this is how we are doing the copy string swap. And in this approach, do you see any problem in this approach for swapping strings? Yeah, so actually we don't need here, good question. So we may not actually need this. This should be good enough because all the strings. Is there any catch? Generally, in general, will this strategy, string swap strategy works? No, we cannot directly use equal to like for numbers. Oh, okay. It's interesting. Not sure. Not sure. It doesn't work. Yeah. Yeah. So Kartikeya got it right. So there could be issues with the length of strings str1 and str2. It could be the case that str1 is actually allocated only 10 bytes and str2 is allocated some 20 bytes. And when we try to swap things, then, maybe a longer length string you copy into a string which is allocated lesser amount of memory, and you could kind of get into that sorts of issues. But in our program, the way we have written that our program, this problem wouldn't come because all strings, they have the same length, which is given by max underscore name underscore length. So because of that, we don't have that problem. But otherwise, we may get into this problem. Are you with me here? You see the problem in the particular swap. As again as this, you don't have this problem when you're swapping numbers because two integers, they have 4 bytes. There is no problem. It's not an issue. Okay. So now, so how many of you looked at the bubble sort code? How many of you looked at, how many of you wrote code for bubble sort? Did I discuss bubble sort in the class? Yes, no? Okay, great. In which case, no, this, so what we are doing here in this sort names function is just that bubble sort. So I think we did it, we did compare, we did it for integers. So what is the idea? There is an outer loop. So in the first iteration of the outer loop, what do we do? In the first iteration of the outer loop, in the first iteration, when I is equal to 0, uh, what do we do? In the first iteration of the outer loop, we bubble up the largest number to the last position. In our case, we bubble up uh, the string which is occurring lexicographically the largest into the last position. How do we do that? Like, for example, so you compare this and this. All right. So like, for example, it can be, so here you may have Venu and here you may have, Satish. So when you compare Venu and Satish, that Venu occurs later than Satish in the dictionary order. So you want to swap. Where is this comparison happening? This comparison is happening using this string compare function. So the string compare function takes the base address of this string and the base address of the second string, and it compares the two strings that are present. And if the string 1 is greater than string 2, it returns greater than 0, the value greater than 0. If they are equal, it returns equal to 0. And if string 1 is less than string 2, then it returns -1. So the string compare function, so we have the str cmp function. It takes two, uh, let me, yeah, so let's take a look at the man page of string compare, man str cmp. So it takes addresses for two strings. You can see it takes the addresses for two strings. So let me, yeah. So this one could point to a string somewhere in the memory, and this S2 can point to a string somewhere in the memory. So it requires the base address. We have to pass the base address of this string, and we have to pass the base address of this string. And what will string compare do? If it returns, if both of them are equal to 0, uh, uh, then it returns 0. And it returns an integer less than or equal to or greater than 0 if S1 is found respectively to be less than. Anyway, so this is what it is. If S1 is less than S2, it returns 0. Sorry, it returns a value less than 0. And if S1 is equal to S2, it returns 0. And if S1 is greater than S2, it returns 1. So this is how the string compare works. Are you with me on the string compare? Shall I move on? Any questions here? Okay. I assume that you are doing all right then. And so here you are comparing string, just trying to bring it up so you can see. You compare these two and two adjacent elements in the array, and if the jth row is bigger than the j plus first row, you do a swap. That's what we are doing here. And to the swap, you give the base address of row j and row j plus 1. That's what we are doing. That's all. So yeah, so and then so let's say here if they are since since Venu is uh, occurs lexicographically uh, later than Satish, so Venu will be moved here and Satish will be moved here. So Venu comes in here, Satish goes there. The swap happens. But let's say after this you have our awesome Jowl. Then what happens is you compare Venu with Jowl, and Jowl, he occurs late. He is greater than Venu, so no swap happens. But when you compare Jowl with the next with high probability, most names don't start with Z, so Jowl keeps getting swapped, and finally he will land up here. And in the next iteration, you just ignore the last element, the person who has bubbled up. No, we ignore, and then we repeat the same process for the rest of the list. That's it. This is how the sorting works. Are you all with me here in this program? You understand what's going on? Great. So this is all looking good. And finally, you print the names. This is how the whole program works. So if you want the names in a reverse order, then you can put less than 0. That is, if row j is less than row j plus 1, then you do a swap, in which case the names will be sorted in the reverse order as against the reverse order means in descending order as against ascending order. Because if row j is less than row j plus 1, then you do a swap, then you are every time you are bubbling up the smallest element. Every time you are bubbling up the smallest element. So GCC name sort 1.c, and then if you so you can see that the names are now sorted in the reverse order. Great. So bool any swap. So Nikhil asked the question. So here, uh, so good question. So let's say I will try to use, instead of using strings, let me use numbers and explain it. So that way it will be easy. Let's say you have something like this: 30, 10, 12, 25. So when you do bubble sort, yeah, so you compare 10 and 30, and then what happens is 10 is smaller than 30. So the state becomes like this: 10, 30, 12, 25. And then after that, you compare 30 and 12. You compare 30 and 12. So 10, 12, 30, 25. And you compare 30 and 12. So you have 10, 12, 25, 30. So now this is one iteration. You have bubbled up the largest element. You have bubbled up the largest element. Now you have to repeat the same process for the rest of the array. You have to repeat the same process for the rest of the array. So you compare 10 and 12. So what happens is 10 and 12, there is no swap is required because 10 is less than 12. So this is the state of the list. And then, and then you compare 12 and 25. And 12 is smaller than 25, so it remains the same. So you have the thing. So you can see, so this is one iteration of the outer loop. When I is equal to 0, this is what happens. When I is equal to 1, this is what happens. So when we, and then you can see, so this 30 remains invisible because we don't touch it in the subsequent iterations. So at the end of iteration 1, you can see that there is no swap is happening, which means that the list is in an already sorted state. So there is no point in, technically speaking, you may say that we have bubbled up 25, but we didn't put any effort in bubbling up 25 because if the list is already in a sorted order, in which case, the any swap will be false, and we conclude that the list is already sorted and we come out of it. So essentially, we use this to kind of optimize our program. So like, for example, on OJ, your TS may, they keep a timing. So if they ask you to write bubble sort code, you may write bubble sort code. And, for many cases, you may not get a TLE, but for few cases, you may get TLE error. Those cases could be the cases where, you have part of the list is already sorted, and you are not using this logic, and because of that you are getting time limiter. Not when I is equal to 1, that Yeah, when I is equal to 1 in the iteration 1, the iniswap has become true. No, no. Why is any swap equal to true when I is equal to 1? You think that any swap means it did any swaps happened. So when you are starting a iteration, you assume that there are no swaps happened, and if there are any swaps happened, you make it equal to true. That's what we do on line number 44. And if no swaps happened on line number 47, then that means the list is already sorted, so you break from the for loop. All right. So Nikhil, does this make sense? Yeah, I don't know how this OJ thing works, but anyway, don't worry about time limit errors. As I said, we will not have any of them in the next exam. Okay, now tell me, so where is the memory for the names allocated here on line number 53? So the names array, where is the memory for it allocated? Where is the memory for names underscore, sorry, for names variable allocated, names array? Yeah, program stack. It is allocated memory on the program stack. Good. So can you tell me what are the problems with this? Do you see any problems? Activation record associated with main is a very good answer, Pranjal. So what is the problem? Is there any problem with the particular approach we took to store the names? What are the problems? Abhinav Thaniru, can you tell me? Aishwarya Bharati, Akshit Gureja, Anish Mathur. What is the name limit issue, Nikhil? Arnav Pandey, Deepti Chandak. So there are two problems here. Number one, what is the maximum size of the name? Is there anyone in this class whose name is greater than 20 characters length? Maybe not. So, but let's say if someone's name, I have your, so that's why I asked you this. Interesting. But the only thing is, we are just storing names without full name. So, Ketu Sesha Sarath Reddy. Okay. Good one, good one. So anyway, so if the name length is greater than 20 characters, then we cannot fit them. Um, there is a second problem. So the second problem is if the number of what do I say? If the number of names is greater than 100, then again we will not be able to handle them, right? So we can say, let's allocate 200, but what if the number of names is greater than 200? So we don't know the number of names that we have to store a priori, so we don't know how much memory to allocate. So that is one issue. Second issue is we are assuming some maximum uh, length for the name, and but if the length of the name is greater than that, again we are in trouble. And we need to fix these two problems. Yes. So we will fix one problem first. The first problem that we will fix is, let's fix the problem so that we will be able to handle arbitrary name lengths, not the number of names, but even if the length of the name could be 20, 10, 30, 40, whatever it is, it doesn't matter. So here, so this is the, so now in order to handle this, you can see online, this is a new program now we are looking at. We can see on line number 61, instead of using 2D array of characters, we are using a array of one-dimensional array of character pointers. One-dimensional. So if you see names now, it is a one-dimensional array of character pointers. Each element is a character pointer. So now, where is the memory for names allocated? Memory for names is allocated where? Where is the memory for names allocated? I asked you this question before. I'm asking this question again now. Great. So, so what happens is, what are the rough date sections that are present in the memory of a program? So actually, let me do one thing. So if I, yeah, now this is very good. So what are the memory sections that are present in a program? So if you ignore the BIOS and other parts, you can see that there will be a data section in which global variables are present. And there is a code section in which code is present. And then there is a heap. This is whenever you allocate memory using malloc calls, memory will be allocated from the heap. And then we have the stack, program stack, which grows this way. So now what happens is, so when we read a name, we use malloc. We know that we compute, let's say, we read Venu from the keyboard. Then we read Venu into a temporary buffer and find the length of it. Okay. And then we use an malloc. We use an malloc to allocate memory for Venu. And the base address of this we will store in the corresponding character array, character pointer array. So similarly, every time we read a name, we allocate memory for it in the heap. So this is stored in the heap. This is stored in the heap. And this memory for these strings are allocated using malloc calls. So we have this whole character array, it's not a character array, an array of character pointers which are present in the stack. This whole thing is present in the stack. So this is your, this is the miniature version of, this is what I am putting here. It's a miniature version of the stack that you have here. So this is, so Venu could be here and you will have a pointer here. And then someone, Satish could be here and then this could be pointing to here. So this is how the layout of the data structure in the memory looks like. And if you go and see, let's go and see how the read names function work. If you go and see the read names function, so what we are doing in the read names function is, so you can see there is this, we read the name into a temporary buffer called as current underscore name. This is current underscore name. So there is a temporary buffer called current underscore name in which we read a name, in which we read a name. And then we figure out what is the length of the name that we have just read, and then use malloc call to allocate that much amount of memory from the heap. And we are adding +1 because we need to account for the null character that we have to put at the end of the name. And then no, you the base address of that chunk of memory that we got, we store it in names of 5, and then we copy the current name into the memory location pointed to by names of. This is how the read names function work. Can you all take a look at this read names function for a moment and see if it makes sense for you? Yes, no? Does it make sense? Read names, how, what is happening there? You use malloc to get the base to allocate a chunk of memory, and that address you are storing it in name cell. So malloc returns void star. It says malloc doesn't know the memory that is allocated, that is written by it, whether it will be used to store no what. So here in this particular case, no, it's the memory that is allocated. It is used for to store a string or an array of characters. So because of that, we typecast it to char star. So every name's length is dynamically assigned, not like dynamic. That's true, because we read a name into some big buffer. We find the length of the name and then we allocate suitable amount of memory using ML. Are you all with me here? I hope. And then the print names function, of course, is very easy. So yeah, but what I would like you to note here is the parameter type now. It's not a 2D array that we are passing. We are passing an array of character pointers. Yeah, that's true. This is for using memory efficiently, basically. No, it's a memory. It has other uses in the sense it's just not the efficiency, right? Like for example, if you get a different, if you fix on the name length as 30, 40, whatever it is, what if you get a name whose length is larger than that? In this example, the purpose for in this example is if we cannot have a large row length in a 2D array because you end up wasting memory. And on the flip side, however large row length you may have, you may end up getting a name which may not fit into that row. Both problems we have. Okay. Are you all with me? So now I would like to pause today's lecture here, and I will post the previous code and this code on the course website or through email. I want you to understand the rest of the program, especially how the sort names function and how swap is working. And we will take up this discussion in the next class. In the next class, we will solve the other problem also and finally close the discussion on this. Okay.